Welcome friends, welcome to this new type of session where we'll be solving some predicted questions for your upcoming GATE examination. Yes. Now in this entire week we saw many videos on open channel flow, right? We saw videos on uniform flow, efficient section and critical flow. Now based on those topics, I will be giving you some of the questions which can be asked in the upcoming GATE examination. Now, will they be the entire syllabus? No, obviously no. But yes, there is a high probability that the questions might be asked from these particular questions. Yes. So let us start the session without any further delay. So welcome all the participants who are attending this lecture live, and also warm welcome to all the participants who are seeing this recorded. Yes. My name is Satyajit Sahu and I have 10 plus years of experience in teaching for GATE and ESE. I have done my BTech and MTech from IIT Kharagpur. Many of the students also know me before, they are attending the classes regularly. Yes. Let us not delay anything and start the class. Okay. Now in this week already I have taken a video on what? Uniform flow, that is Manning's equation, because Manning's equation is used to determine the velocity and discharge in a uniform flow. Right? Let me just revise the equation which we learned in this particular lecture. What we learned? That the velocity in case of uniform flow is what? 1 by Manning's constant. Yes. Then the hydraulic radius to the power 2 by 3 and then bed slope to the power half. This was the equation, right? And what will be the discharge? This will be simply what? Velocity into area. So this was the very basic equation of what? Your Manning's. Yes. Now based on this we solved some question, and today also we'll be solving some more question based on what? This Manning's equation. This Manning's equation. Let us solve them. So this is the first question. This is the first question. What is written? A wide rectangular channel has a slope of 0.0004 and Manning's roughness coefficient of 0.02. The discharge is given 2.54 meter cube per second per meter. What is this meter cube per second per meter? Yes. Normally what happens? Discharge is what? Meter cube per second, right? Now what is this per meter? That means this is discharge per unit width. That is what? Q by capital B. This is what? Discharge per unit width. Estimate the normal depth. Normal depth means what? The depth of flow. That is, I can say Y. Depth of flow. It's a rectangular channel. But see the words. What is written? Wide rectangular channel. So whenever they write wide rectangular channel, what does that mean? That the width is quite large compared to what? The depth. In that case, what happens? I have already told that in the video which I took on Monday, right? But let me revise it for you. That in that case, what happens is your radius is what? Hydraulic radius, that is A by P. Now area is what? Area is B into Y, and the weighted perimeter is what? B plus 2Y. Yes or no? But since width is very large, so here in place of B plus 2Y I can only write B, and this B get what? Y. So you can replace this R with what? Y, depth of flow in case of a wide rectangular channel. Then what happens? What becomes the discharge? The discharge becomes velocity into area. What was the velocity? 1 by N, R to the power 2 by 3, then S to the power half. Then what is area? Area is B into Y, right? For a rectangular channel, what is area? Yes, if we have a rectangular channel like this, what will be the area of this? The area will be simply this width into Y, right? Here what happens, in place of radius I can write down what? Hydraulic radius, what I can write down? Y only. This I just proved for a wide rectangular channel. So this equation can be written as what? 1 by N, yes, Y to the power 2 by 3, yes, then S to the power half, then B by B into Y. Now what I can do, I can take this B, I can divide both sides by B. So what will happen? This B will vanish, yes, and what this will become? Q by B is small q, right? Discharge per unit width. Yes. And this equation changes to what? Y to the power 5 by 3 S half. by n is equal to small q. It's a very important equation. It's a very important equation. You can solve many questions in the GATE examination where they ask questions from this particular section of what? Manning's equation. Yes. Now using this equation I will solve the question. Using this equation I will solve the question. Yes. So q is given. What is given? Q is given as how much? Q is given as 2.54. This I will equate to what? Y to the power 5 by 3. Yes. Then slope is given. Is given how much? 0.0004 to the power half then. Yes. And then Manning's constant is given what? 0.02. You see in this only y is unknown, right? Now I can find out y very easily. I can write down y to the power 5 by 3 is equal to, I can say 2.54 into 0.02 divided by the square root of what? 0.0004. Yes. Now this I got as y to the power 5 by 3. If I want to find out y, I'll do 3 by 5 here. Or I can say to the power how much? 0.6. So you see, so nicely systematically we are able to solve this question. Let us find this y using the calculator. Yes. So 2.54 into 0.02 divided by square root of, 2.54 into some error happened. Let me change it the thing. Yes, okay, now it is fine. So 2.54 into 0.02, okay, divided by 0.000, or can I say square root of 0.0004. Now whatever it let, I will do a to the power 0.6. So I am getting 1.75 meter as the normal depth, or I can say depth of flow. So you see, you can solve this kind of questions by easily understanding some simple logic and some simple conclusions. All these conclusions are very important and all these questions are regularly asked in the GATE examination. Let us go to the next question. Hope you are all liking this session. If you are liking this session, then please like the video and subscribe to the channel. Let us go to the next question. What is written? In a wide rectangular channel, an increase in normal depth by 20% increase discharge by, okay, it's a very interesting question. What is again written here? Wide rectangular channel. If it is wide rectangular channel means what? Your R will be equal to Y. I just proved. Yes. And I can write down discharge as what? Area into velocity. What is velocity? 1 by N in place of Y. In place of R I can write Y. What is power 2 by 3? Then S half, and area will be how much? B into Y. And this equation changes to what? B into Y to the power 5 by 3 S half, then divided by N. Now you see this equation of discharge for a wide rectangular channel. If other parameters are same, can I say this discharge is varying with what? Y to the power 5 by 3. Yes, normal depth means Y. So it is varying with what? Y to the power 5 by 3. If other parameters are same, like width is same, roughness coefficient is same, bed slope is same. Yes. Now in this question, what is written? It is written that the normal depth increases by what? Your 20%. That means what? If initially discharge was Q1 and Y was Y1, yes. So when the depth change from Y1 to Y2, what will be the new discharge or the increasing discharge? Now you can see that Y2 is actually equal to 1.2 times of Y1. Yes. How? How? Because it's in what? The normal depth increases by 20%. So if it was Y1, increase of 20% means what? 1.2 times of Y1. Yes. Now what is asked? Increase in discharge. The percentage increase in discharge. Suppose percentage increase in discharge. Now what will be the percentage increase in discharge? See, discharge was initially Q1. It increased to Q2. So the percentage increase will be what? Q2 minus Q1 divided by what? Q1 only, na? Because it is changing from Q1 to Q2. So denominator will be what? Q1. So change is Q2 minus Q1 and original is what? Q1, right? Now this I can write down as what? You see, Q is directly proportional to Y to the power 5 by 3. So here I can write down Y2 minus Y1. But what? Power 5 by 3. Power what? 5 by 3. Why? Because you can see that Q varies with y to the power 5 by 3. Yes, so I can write down this equation, very important equation. So now what happens, I'll solve this. Now y2 I can write down what? 1.2 times y1 to the power 5 by 3. Yes, and then minus y1 to the power 5 by 3. Yes, and then divided by y1 to the power 5 by 3 and then into 100. Very easy, right? Now you see, in numerator denominator y1 to the power 5 by 3 gets cancelled, and what I get this in different expression, I can write down 1.2 to the power 5 by 3 minus 1 to the power 5 by 3 divided by 1 to the power 5 by 3. Interesting, right? Into 100, because you're finding what? The percentage increase. So this you can easily find out, right? This will be 1.2 to the power 5 by 3. Yes. Now see, other terms are 1 to the power something. That will be 1 only, na? So this will be 1.355 minus 1 divided by 1 into 100. So how much are getting this answer? This answer getting is 35.5%. Okay. Now this question can be asked in many different ways also. Same thing with different data. How? I'll just tell you so that you can solve it very fast. Pardon me. So you can see that this increase in discharge, how you are writing? This Q2 minus Q1 by Q1 into 100. This I am writing as how much? I am writing this as y2 to the power 5 by 3 minus y1 to the power 5 by 3 divided by y1 to the power 5 by 3 into 100. Now when the increase was 20%, then y2 was equal to how much? 1.2 of y1, and therefore this value I was getting how much? 35.5%. If I say that the normal depth increased by 10%, yes, the question can be asked in this manner also, right? So if I tell that y2 is equal to 1.1 times of y1, yes, means what? The increase in 10%. So what will be the increase in discharge? In that case, this will be how much? 1.1 to the power 5 by 3 minus 1 by 1 into 100. So how much I will get? You can see, you can solve so fast, right? Efficient, smart. So 1.1 to the power 5 by 3. Yes. And then minus 1 divided by 1, getting how much? 17.22%. Yes. Now same thing if I ask you. That if the increase of depth was 30%, means what? Your y2 is equal to 1.3 times of your y1. In that case, the q2 minus q1 by q1 will be equal to how much? If I want to find out the percent increase in discharge, that will be simply what? 1.3 to the power 5 by 3 minus 1 by 1 into 100. You can see that you can solve very fast this question if you are understanding the method very nicely. Yes, you can see here it increases how much? It is 54.84%. I'll just recheck this value. 1.3 to the power 5 by 3. Yes, I am getting this percent. So you can easily solve this. But here the catch is what? It should be a wide rectangular channel. Then R will be equal to Y, and I can say the discharge lateral proportional to what? Y to the power 5 by 3. This can be only applicable for what? Wide rectangular channel. Very nice, very good. Let us solve another question now. Okay, this is what? Trapezoidal channel. This is what? Trapezoidal channel. The trapezoidal channel is what? 10 meter wide. It is what? 10 meter wide. Okay, very good. It is written 10 meter wide. Beautiful. Means B is given 10 meter. So this width is how much? This width is 10 meter. The side slopes are given 1.5 horizontal is to 1 vertical. Okay, the side slopes are given what? The side slopes are given as 1 vertical is to 1.5 horizontal. Very nice. Yes. The bed slope is given as 0.003. So as I can write down what? 0.0003. The Manning's constant is given how much? 0.012. You have to find out the velocity and discharge when the normal depth is 3 meter. The y is what? 3 meter. Now this question you can solve very easily. First of all, you have to know that whatever might be the cross section, the discharge will be what? Area into velocity, and the equation of velocity will be what? 1 by n r to the power 2 by 3 s half, because it's a uniform flow, and r will be always what? Your r will be always equal to your area by your perimeter. Area by what? Perimeter. Very nice, very good. Yes. Now you see here, only what will change? The expression for area and weighted perimeter will change for rectangle, trapezoid and all, right? Now we should know how to find out the area of a trapezoid. I'll do it in a very generalized manner, and then we will apply to this particular question. You see, this is B. This is B. Suppose this is your depth y. Yes, suppose this is depth y. Now see the side slopes. Suppose the side slopes are like this. The side slopes are like this. One vertical is to, suppose m horizontal. I am generalizing m horizontal. Yes. So if this is y, this will become what? This will become my na. This will become what? My na. Because one vertical is to m horizontal. So if vertical is y, that will be what? M into y. Yes. And this also will become what? M into y. So if I want to find out the area of this trapezoid, what will happen? You can see central you are getting a rectangle, right? And what is the area of this rectangle? This rectangle, central rectangle will what? It's a rectangle, so width into depth. So this will have an area of b into y. Now you can see that this is a triangle and it's a right angle triangle. So I can say half base into height. Base is how much? M into y, and height is how much? Y. So I can say your m y square by 2. Similarly, this triangle will be also having what? M y square by 2. So total area, if I write down the total area of this trapezoid, generalized equation will be what? The central rectangle by, then we have triangles whose area is my square by 2. There are two triangles, so multiply, I get what? Your my square. So this I can write down, if I take y common, b plus my. So remember this equation. This is the equation to find out what? The area of a trapezoid. The area of a trapezoid. So I can write down here, right? The area of a trapezoid is what? B plus my into y, where b is the bottom width, right? You can see b is what? B is your bottom width, and y are what? The depth, and m is what? The side slope. Yes, so nice. So here I can apply this and find out area, right? What will be the width? The width is how much? The width is simply here. You can see the width is how much? The width is given as 10 meter. So width is 10 meter. The side slope is given what? 1.5 horizontal. So m is your 1.5. So 1.5, and depth is given what? 3 meter. Yes. See the question. This is width. This is your m, and this is what? Your y. So nice. So nicely you can find out the area. How much it is coming? Let us find out. It is 1.5 into 3. So whatever I am getting, I'll add 10 to that, and then into 3. I am getting area of 43.5 meter square. This is the area. This is the area. Very nice. Now what is the weighted perimeter? Let me go back to the diagram. So I will clear this. You can see that weighted perimeter is this one. Yes. And then this one. And then this one. Yes. You see, this is B only, right? Now see, if this is y and this is my, then using Pythagoras theorem, this will be what? Square root of y square plus m square y square, right? And if I take y square common, so square root of y square will be what? Y. So this will be y into root 1 plus m square, the side length from here to here. Yes. And this also will be what? This also will be y into root under 1 plus m square. Beautiful. So I can say that the weighted perimeter will be how much? B plus 2 times of y root under 1 plus m square. Beautiful. Yes. This is simple geometry. These are all simple geometry. So I can put here and find out the weighted perimeter. B is how much? 10 meter plus 2 into y is how much? 3, and then root under side slope is 1.5, and then square. Let me find out this weighted perimeter. So the root under 1 plus 1.5 square. Okay. then multiply by 6, and then I will add 10. I'm getting a value of 20.817 meter. Yes, weighted perimeter also I got. Now weighted perimeter, how much I got? 20.817 meter. So what will be your hydraulic radius? That is what? A by P. So A is 43.5 and P is 20.817. Let me write down the hydraulic radius, that is 43.5 divided by 20.817. I am getting how much? I am getting a value of 2.09 meter. You see, ladies and gentlemen, in the GATE examination, you will be asked such questions. So if you are seeing for some shortcuts, some fun tricks, some socking data and all, you will get sock in your examination. Yes. So don't go after socking data. Many people are doing socking data videos on the GATE, how many appeared, how many registered, that doesn't matter to you. If you're unable to solve this question, all those data are what? Are useless and futile. So my suggestion will be that you focus on solving numericals in this manner and be systematic, be as focused as possible, be as disciplined as possible. Don't go into the gimmicks of socking data, how many registered, how many appeared, and all those stuff. That is not going to help you. Yes, what is going to help you is that if you have solved the questions in a systematic manner like this, then only you are going to get a very good rank in the GATE examination. Okay, so now let us come back to the question. So I got hydraulic radius what? 2.09. Now you can easily find out what? The velocity. It will be what? 1 by Manning's constant. What is Manning's constant? Given 0.012. 1 by 0.012. Then what is the hydraulic radius? It is 2.09 to the power 2 by 3, and bed slope is given how much? 0.0003. So 0.0003 to the power half. Yes, very nice. So how much I am getting this velocity? Let us see. 2.09 to the power 0.67. Okay, divided by 0.012 and then multiplied by square root of 0.0003. So I'm getting a velocity of how much? Almost 2.37 meter per second if I approximate it, right? And discharge will be what? Area we already know, 43.5 into 2.37. So how much I'm getting? 2.3. Actually we got 365. Let me take 365 and then 43.5. I'm getting almost what? 102.88 meter cube per second. So you can see that this type of questions will be asked in the GATE examination 2 marks. And if you want to solve this type of questions, you have to be very systematic and you should know the exact method how to solve questions. Okay, so this was on uniform flow. Also we saw hydraulic efficient section. This we saw in the Wednesday. This Wednesday we saw this video, right? And students followed also. Now based on this hydraulic efficient section, they will ask some questions. Let us solve some questions from hydraulic efficient section. So this question is what? A rectangular efficient section of flow depth 1.25 meter. Yes, and discharge is given 12 cubic. Means what? Your Q is given 12 cubic meter cube per second. The Manning's coefficient is given and the flow depth means what? This is Y. Which of the following statements are correct? And it's an MSQ question. It is what? An MSQ question. So first of all, it is given what? A rectangular efficient section. It is given what? A rectangular efficient section. Right? Now, we have some conclusions for a rectangular efficient section. What were those conclusions? We saw earlier. I will just revise them. That in a rectangular efficient section, the width is how much? 2 times of your Y. It is only applicable for what? A rectangular efficient section, not for all rectangular sections. It is only applicable for what? Rectangular efficient section, right? So we saw that the width is 2 times of depth. Yes, and we saw that what was the hydraulic radius? It was Y by 2. It was Y by 2. So let us come to this equation. It is written the width of the channel is 0.625 and width of the channel is 2.5. Which one is correct out of this 1 and 2? We know that width is what? 2 times of Y for what? For hydraulic efficient rectangular channel. So this means what? 2 into Y is given 1.25. So this is what? 2.5 meter. So out of this 1 and 2, this 2 is correct Yes, this 2 is correct and 1 is wrong. Now we have to see the bed slope. Bed slope also 2 options are given. Which one is correct? We'll see. For that we'll take the help of what? Manning's equation. Now what was the Manning's equation? Q is equal to area into your velocity. What is area? Area is B into Y. Yes, B into Y. And then what is velocity? 1 by N. R to the power 2 by 3. And then bed slope to the power half. You know the width, right? Width is how much? 2 times of Y. So this I can write down as what? 2y into y, making it what? 2y square. And then we have r is equal to y by 2. Yes, so I can write down as what? Y by 2 to the power 2 by 3. Then this Manning's constant is there. And then s to the power half. Now if you see, we know y, right? We know y. Y is how much? Y is 1.25. We know also n, it is 0.02. We know discharge, it is 12. Now here I will put everything. Here I will put everything, you see. I write down 12 is equal to 2 into y square. Y is how much? 1.25. So 1.25 square. Now divide by what? The Manning's constant given is how much? 0.02. So 0.02. Then y by 2, that is what? 0.625 to the power 2 by 3, and then s half. You see the only thing unknown is s. So from here you can find out s. Let us find out s here. Let us find out s here. If I solve this, I'll do. You will also do with me. So 12 into 0.02, then divide by 2, then divide by 1.25 square. Okay, and further divide by 0.625 to the power 0.67. Yes, then whatever I'll get an s. So what I will do, I'll square it. So when I square it, I am getting how much? S is equal to, I am getting 0.011 approximately. I am getting what? S is equal to what? 0.011 from this equation if I solve this. So if you see, which is the right answer? B is 4th is right, and I can say this is wrong. So you see how nicely we are able to solve this MSQs, yes, by knowing the basic concepts. Now many students ask me, sir, how to solve MSQs? You see, you don't need any extra skill to solve MSQ questions. Remember that you don't need any extra skills to solve MSQ questions. You can solve MSQs questions if you know the concept. If you know the concept, you can easily solve. There is no requirement of any additional, skills to solve MSQ's question. You know the concept, you know how to solve numerical. See, solving numerical, it is MCQ. Yes, it is numerical data entry question. Okay, where there is filling the blanks, or it is MSQ. If you don't know how to solve the numerical, then you can't solve neither NAT, neither MCQ, or neither MSQ. Yes, so focus on your numerical solving abilities. Yes, focus on what? Your numerical solving abilities. Don't think that you need any extra skill or talent for solving this type of questions. You need only one talent: how to solve questions. That's it. Yes. Okay. So let us go to the next question. It is in what? An efficient triangular channel has a depth of flow 1.25 meter. Yes, it's written what? Efficient triangular channel has a depth of flow 1.25 meters. So y is given. Yes, the Manning's constant is given and the slope is given. It is asked to find out the discharge. How to find out? Very easy. Remember that for an efficient triangular channel, you see, in an efficient triangular channel, what happens? In that case, it is having an apex angle of 90 degree. Yes, this is the feature of what? Efficient triangular channel. Yes, if this is 90 degree, that means what? This is 45 degree. If this is 45 degree and this is your y, this also will be y, this also will be y. In this case, what will happen to the area? The area will be, you see, half base into height. So base is 2y and height is y. So how much I get? I get y square. So area is what? Y square. Yes, if I see the side slopes, you see the side slopes, this will be how much? I can say root under what? Y square plus y square, Pythagoras theorem, y square plus y square. Yes, it is right angle. Yes, so that I can say root 2y, right? It is root 2y. So if this is root 2y, this also will be root 2y. So what I can say about the weighted perimeter? It is 2 root 2y. Yes, so what will be hydraulic radius? It will be area by your weighted perimeter, giving me how much? Y by 2 root 2. So these are the conclusions for what? Efficient triangular channel. You should remember these things. Yes, if you remember these things, you can easily find out what the discharge. What is the equation of discharge? Discharge is what? Your area. Area is by the how much? Y square. Yes, into velocity. Velocity is how much? 1 by n, right? And then r to the power 2 by 3. R is how much? Y by 2 root 2 to the power 2 by 3, and then bed slope to the power half. You see, you know your y, right? Y is 1.25. So I can write on 1.25 square divided by Manning's constant is how much? It is 0.017. Then you can see y. Y is how much? 1.25 divided by 2 root 2, then to the power 2 by 3, and s is how much? S is 0.004, and then to the power half. Yes. So now I will ask the students, this lecture is recorded or live? If some students can tell this is recorded or live, then I will, they can message me to my number. So I'm giving my number. Okay, so you message to my number that this lecture is recorded or live, then I will give some prize to you. 886 724 and then 7774. So let us see that whose students are listening to this lecture very attentively and they are telling that this lecture is live or recorded. Okay, nice. Okay, let us solve this question. So I'll solve this. 1.25 square divided by 0.017. Then I will do this calculation. 1.25 divided by 2 divided by root 2, and then I'll take the power 0.67, then I'll multiply 1.25 square, then I'll divide by 0.017. Yes, very nice. Okay, then I'll multiply by square root of 0.0004. So I'm doing the calculation. I'm getting a discharge of how much? 1.06 meter cube per second. Yes, so you can see by just remembering this conclusions of your hydraulic efficient triangular channel, like that we remembered for rectangular, you can solve these kind of questions. Okay, very nice. Let us go to the next type of questions which are asked in open channel flow. I've already taken this lecture yesterday. I took, right, critical flow, right? So critical flow video is available in the YouTube channel. Okay, you can see that lecture if you want to solve these questions. Let us solve one question of critical flow. It is written, calculate a discharge of a rectangular channel if width is 4 meter and critical depth is 1.7 meter. It's a rectangular channel, right? And you should remember that your YC for a rectangular channel is how much? It is simply Q square by G to the power 1 by 3. Very good. Yes. Now, what is small q? It is the discharge per unit width. Yes, very nice. So your critical depth is given. Can you find out small q here? Very easy. So 1.7 cube, I can cube this. Yes, will be equal to q square by g. So from here I can say q will be 1.7 cube. 1.7 cube into g is what? 9.81. Then I'll take a square root. Let us find out q then. Small q, what is small q? 1.7 cube, then multiply by 9.81, and I'll take a square root of this. I'm getting how much? I'm getting this as 6.94. I'm getting this as what? 6.94 meter cube per second per meter, because this is what? Discharge per unit width. If I want to find out discharge, that will be what? The small q into b, that is how much? 6.94 into your b is 4 meter, giving me how much? I'll multiply 4 here. If I multiply 4 here, I'm getting approximately what? 27.77 meter cube per second. So discharge I'm getting how much? From this calculation I'm getting how much? I'm getting a value of 27.77 meter cube per second. So this is a very, we can say, frequently asked question in a GATE examination, where they try to know that, the basic equation for finding the critical depth in case of a rectangular channel. Similarly, they will ask about what? Triangular channel also. Now triangular channel, the equation is a little different, right? It is what? It is YC is equal to, I have explained these things in this video. You can refer to this video. I have done the derivation also. So here YC is how much? It is 2q square, discharge square, divided by g into m square, and to the power how much? To the power 1 by 5. How much? 1 by 5. Yes. Now here, what is this m? This is the side slopes, right? If you have a triangular channel like this is what? Side slope. This is 1 vertical is to m horizontal. Yes. Yes, that's written. So what is written? The discharge of a triangular channel when m is given as 0.6 and discharge is given how much? 6 meter cube per second. Find the critical depth. It's very straightforward. You have to just put the equation, right? So 2 into q square means 6 square divided by g is 9.81 into m square. M is 0.6, so 0.6 square. And then to the power 1 by 5, it is what? 0.2. Let us solve this question. 6 square divided by 0.6 again square, okay? So, and multiply by 2 divided by 9.81, and then I'll take a power of 0.2. How much I'm getting? I'm getting 1.83 meter as what? The critical depth. Yes, you can easily solve this question. Yes. So these formulas I have derived in this particular video. You can refer to this video and easily understand how to find out the critical depth in case of a rectangular channel and also in a triangular channel. Now I'm giving this question as homework. Let us see that which student solve this homework very nicely. So either you can solve this homework and write the answer in the comment section, or you can message me also on my number 886 724 sorry and then 7774. So either you can solve and write down the answer in the comment section, or you can message me. Now obviously it's not the end of all all the knowledge about open channel flow. Yes, in this week I tried to make you understand, I can say, the important concepts. Okay, so earlier we had this lecture on uniform flow, if you remember, on Monday. Yes, then I explained this hydraulic efficient section on Wednesday. Yes, and then yesterday critical flow lecture happened. Yes, these 3 lectures I took, and today is what? We're solving questions, and we solve many questions also, the predicted questions I can say for upcoming GATE examination. But yes, it's not the end, and if you want to solve more questions and understand more better about open channel flow, I have recorded many lectures in open channel flow. They will be available in the section of Learn with Video Lessons in the BYJU'S exam prep app. Yes, and if you face any difficulty, you can always message me. I will guide you. Yes, you can see that all the videos are recorded chapter wise, and you can see that they are mentioned in a very systematic manner like this. Yes, so please see these lectures, and if you want any help, you can always contact me. See you in some other video. Thank you very much.